once more. This is the third lecture on reflection of light. 2 lectures already you have been received. Now in the third lecture, I am going to discuss with you the numerical part, mirror formula, magnification, basically linear magnification. Now, first of all, we have to understand the sign conventions used in case of spherical mirrors. Children, regarding sign conventions, the exact diagrams with their respective postulates, mirror formula and linear magnifications formula, already 3-4 pics has been provided to you so that you can copy down from there only. But to make it understood, I am discussing first of all the sign conventions. In the sign conventions, these are basically based on the Cartesian plane. Children, if you consider this page as a Cartesian plane, say this is your y-axis and this is your x-axis, then as per the sign conventions, the pole is considered as the origin and the principal axis considered as an x-axis. All the distances measured from the pole, whether towards left or towards right. Children, whenever you measure any distance towards left side, it is always negative. Whenever you measure any distance perpendicular and above the principal axis, it is always positive. And any distance which is measured in the downward directions, say in case of your real and inverted image, it is always negative. Similarly, the distances which are measured towards the right side, they are always positive. This is positive. These all points as well as diagram already provided to you in the beginning of this lecture. And to understand the other thing, mirror formula. The mirror formula is a formula which relates the focal length, image distance, object distance with a relation. The relation is 1 upon f is equal to 1 upon v plus 1 upon u. Now v is image distance, u is object distance, f is focal length of the spherical mirror. Children, also keep in mind that focal length and radius of curvature are also related to each other. The formula for that is f is equal to r upon 2. That means whenever you divide radius of curvature with 2, you will get the focal length. You can pause my video anywhere if you feel it difficult to understand, and you can take the screenshot of these images also. Now, after that, I will let you know something about the magnification. Magnification, you children already know when we were talking about the size of the image. Sometimes size of the image was enlarged, sometimes size of image was smaller. So this is all because of the magnification. Magnification means how much it is magnified. It is reduced by some factor or it is increased by some factor. So magnification produced by a spherical mirror, it is given by height of image divided by height of object. That means it is the ratio of height of image to the height of object, and it has no units because similar quantities are divided. Also, it has been calculated by another formula, that is minus v upon u. If I club these two, I can get magnification is equal to h dash upon h is equal to minus v upon u. Children, I want to let you know one more thing about the magnification. The magnification is basically telling you the nature of the image. How? If magnification is positive, then the image is virtual and erect. If magnification is negative, then the image is real and inverted. So this is all about your formula to be used in your numericals. I have clearly explained magnification, and the certain pics are helping you that how to write in a copy and how to understand. I will be providing you 2-3 demo answers of the numericals, and then certain questions will be given to you to solve. In case of any problem, Karanjit sir is always available with you. You can ask any query to Karanjit sir. No problem. Numerical, which is basically based on your concave mirror. See, this concave mirror I have already circled so that it should be very clear that this mirror is a concave mirror. Now let me read first of all, an object of size 5 centimeter, size means your H, placed at 25 centimeter from a concave mirror. Placed at means this is object location. Of radius of curvature 30 centimeter, calculate number 1, position of image, that is V to be calculated. Nature of image, easily we can find out from the magnification. I have already explained magnification will let you know the nature easily. Third, size of the image, H dash. Children, as it is clear from it that size is what? 5 centimeter. I have written size 5 centimeter, H. Then U, position of object, that is 25 centimeter, 25 centimeter. If you look into the sign convention, object is always kept on the left hand side, so it is negative. And radius of curvature 30 centimeter, which is mirror? Concave. The concave mirror radius of curvature lies where? Left hand side. So it is minus 30 centimeter. Calculating focal length, dividing it by 2, I got minus 15 centimeter. Now mirror formula, you know very well, 1 upon f is equal to 1 upon v, 1 upon u. And when you substitute its values, it is 1 upon minus 15, 1 upon v plus 1 upon minus 25. Just like a 4th standard student, when you solve it, it's the solving fractions only. Minus 1 upon 15 is equal to 1 upon v minus 1 upon 25. Now shift this term toward the left side. On shifting this term toward the left hand side, you will see this minus 1 upon 15, this becomes plus. And 1 upon v. What is the LCM? LCM is 75. When you operate it, here you will get minus 5 and plus 3. And when you subtract, you will get minus 2 upon 75. This is 1 upon v. Now reciprocate both sides. When you reciprocate, what you will get? V is equal to minus 75 divided by 2. On calculating, it is minus 37.5 centimeter. This is location of image. Now calculate the magnification. Magnification is minus v upon u. That is minus of minus 37.5 divided by minus 25. Minus get cancelled with minus. And 375 divided by 10, because point has been removed, negative sign as such, and 1 upon 25 here. When you do the cutting, 25 directly cut 375 with 15. And on calculating, it is minus 1.5. Children, what is it? Negative or positive? It is negative. So the image is real and inverted. Now, we want to find out the third part, that is your size of image. Size of image, h dash upon h is equal to m. Or h dash divided by size of object was 5. This is equal to minus 1.5. On multiplication, h dash is equal to minus 1.5 into 5, which comes out to be minus 7.5 centimeter. That means size of the image is minus 7.5 centimeter. Negative is only highlighting that the image is real and inverted. I am giving you a 2 to 5 seconds, 10-second pause so that you can easily look into the page. Then I am going to shift to the next numerical. That numerical is based on your convex mirror. Previously it was based on concave mirror. So I have specially circled this as that is a convex mirror. Now let me read it. A convex mirror used as a rear view mirror. In the uses of mirror, you know it is a rear view mirror. Has radius of curvature 3 meter. 3 meter is radius of curvature. An object size 100 centimeter, that is h. Located at 5 meter from it, calculate position of image v, nature of image m, and size of image h dash. Children, it is clear that size is 100. I have written size 100 centimeter. Location of object is very much clear that it is located 5 meter from it, minus 5. Why minus 5? Use sign conventions. Object is always located on the left hand side. Radius of curvature, that is your convex mirror. So it is plus or minus? It is plus. Plus. Reason? The mirror is convex. So f is equal to plus 3 by 2 meter. So plus 1.5 meter. Now by mirror formula, 1 upon f is equal to 1 upon v plus 1 upon u. Now substituting the values, 1 upon f I have kept as plus 1.5 and 1 upon v plus 1 upon minus 5. This minus 5 automatically replaced this plus sign. Now this point also removed. 10 upon 15 is equal to 1 upon v minus 1 upon 5. On further calculation, shifting the 1 over 5 on this side. Previously it was negative, now it is positive. 1 upon this 10 upon 15 plus 1 upon 5 is equal to 1 upon v. Taking LCM 15. When you take LCM, it is 10 plus 3. That means 13 upon 15, 1 upon v. V further, when you reciprocate 15 upon 13, it is 1.15 meter approximately. This is the location of the image. Now we have to calculate its nature. Magnification minus v upon u. I have quoted here exactly the fraction value, that is minus 15 upon 13 divided by minus 5, minus minus cancels. Further solution, 15 divided by 13 divided by 5 also, when you cut 3 upon 13 and approximately value comes 0.23 with no units. So magnification. So naturally image is virtual and erect. Now calculating the size of the image. H dash upon h is equal to m. H dash divided by 100 centimeter is equal to 0.23. Further cross multiplication, h dash is equal to 0.23 into 100 centimeter, which comes out to be 23 centimeter. Clear? This 23 centimeter is the size of the image. Once more I am children making it clear. Keep in mind this r is here positive. Clear? That is why especially I made it positive clearly so that this thing comes into your mind because of your convex mirror. Similarly, whenever the mirror is used as concave, this R is your negative and focal length will also be negative. The last numerical, this is a second. There are two types of numerical because this is classroom is being conducted on the online classes. So I hope these two numericals are